Okay, so welcome to our first little movie on Earth movements and plate tectonics. Our objectives at this time are to, one, be able to explain how the heat of the core creates what's called a convection current within the mantle. Two, know how the process of plate tectonics is fueled, and it's actually fueled by those convection currents. And we're going to learn more about that here in a second. This slide shows some vocab that you're going to need to know and some vocab that we already know. So over here to the left, you're going to see some vocab that you're going to need to know at the end of this little slideshow. And lastly, we should all know what a convection current is, but now we're going to put them into effect on how the Earth uses them and how that causes plate tectonics. What we have here is the inner layers of the Earth. So the top section, the crust right here, is this little brown outer circle. That's where we live. That's where plants, trees, all those grow. So just below that is the mantle. The mantle is the most important to us right now because that's where plates start to move. That's where we get into plate tectonics. How they move is due to the inner and outer cores. Some people like to break up the inner and outer core into two. Some people like to leave it as one giant inner core, but we're going to split it up into inner and outer. This slide is we're going to start talking about the core and what it actually does to the mantle. So we know that the core is extremely hot, very, very hot. And what it does is it's so hot that it actually liquefies rock. And that liquefied rock is what we call magma. So if I move that, magma is liquefied rock. That is one of our key terms that you will have to know from this little slide. So we know that the core is extremely hot. When something becomes really, really hot, it becomes less dense. And we all know that heat rises. So if we have heat here in magma, what it does is it slowly starts to rise up to the top of the surface. But then there's more magma behind it pushing it up. So what happens is it can only go one place. It goes to the side. When it goes to the side, it starts to cool down a little bit. And what happens when it starts to cool down, it starts to sink back down into the core of the Earth. And once again, there's more behind it pushing it. So it goes back to the side. When it goes back to the side, it gets heated up, and it creates this cycle all over again. It keeps going through this convection current. This is the same way that homes are heated, and that how water boils in a pot, how an oven works. So this is actually how plate tectonics works at the same time. So imagine this current now with a big city on top of it, and it's moving that city to the right. And that's exactly how plate tectonics works. This slide is showing some definitions that we may have already talked about or just about to talk about. So the first one is plate tectonics. We just talked about plate tectonics. We just saw how it works. So it's the Earth's crust is made of moving slabs of rigid rock that slowly move on the mantle below. So this can also be called continental drift. We can use those terms pretty interchangeably. So the cool thing with plate tectonics is that it's moving on the mantle. The mantle isn't exactly liquid either. It's a solid. But when we think about it in the time span of geology, which is millions and thousands and almost billions of years, it acts like a liquid. It moves in small portions every now and then. It's what's called a viscous liquid, like honey or syrup. The one we haven't talked about is the mid-ocean ridge, or the moor. This is caused by those convection currents which pull the plates apart. When the plates are pulled apart, magma rises up and creates mountains that are separated by a deep valley. And on the next slide, I'm actually going to draw a picture that you'll be able to see this a lot easier. As we talked about in the previous slide, I was going to show you what a mid-ocean ridge is, or a moor. So what's happening here is we have our two mountains on the side. So we have a mountain here and a mountain here. Those are just underwater mountains. And in here we have a deep little valley. A valley is just a little dip in the ground, and the opposite of a mountain, basically. So what's happening is that the convection current is going on. So we know that the heat rises, comes to the top, and gets pushed to the side. And this happens actually on both sides. So what's happening is these slabs are being pulled apart. That's what's creating this little valley down there. But also what's coming up is magma, or lava, or liquefied rock. And what's happening is those are building the mountains. So what geologists have been able to do is they've been able to what's called carbon date these things. And they find that in this area here, in this valley, is the newest rock on the planet, brand spanking new. So that's where the youngest rock on the Earth is. And this is how a mid-ocean ridge works. Now that we know what a mid-ocean ridge is, and we know that in this area, this is where brand new continental rock is made. This is where the Earth is making new rock. So later on, what we're going to learn is where the rocks, I guess, to say sadly, die or go away. And it's this whole recycling period of rocks die, they get melted down, they get pushed back up, and it creates this cycle of new and old rock. We're going to get into that a little bit later into the next slideshow. So we're back to the first slide, just explaining what our objectives were, and we'll see if we hit them or not. So, objective number 1, be able to explain how the heat of the core creates a convection current. So we know that the heat of the core creates the convection current, the hot magma rises, gets pushed to the side, goes down, back in, and it cycles through. So we know we hit that one pretty well. 2, know how the process of plate tectonics is fueled. So plate tectonics, like we said, is the movement of the crust, the movement of the slabs we live on. And it's actually fueled by this convection current. So by answering number 1, we pretty much answered number 2 at the same time. So if I went too quickly or the slide goes too quickly, you can easily pause it, take a look at it, go at your own speed, rewind, pause, go back, anything you need to know. Get used to these terms, be able to use them. And the next slideshow we're actually going to talk about is with recycling of Earth's rock. We already know how it was made with the mid-ocean ridges, but now we're going to start talking about where does the rock go to kind of die or get recycled. So I hope you like this. Take a look and enjoy.